This is tutorial second of Cadence Virtuoso IC615. In this tutorial, I'll be showing how to create symbol. So first of all, whenever your design is over, like you are sure about your design, you have checked through your simulation, then the next thing you have to go for layouts. So for that, you have to remove all those voltage source which are and current source which are using in your circuit, and you have to replace them with pins. So for that, I have deleted all those sources here in an inverter, and so what I'll be doing, I'll be creating different pins. So I'll go here, I'll create a pin, or I'll just press P for pin, and I'll give VDD in, ground, and out. The thing is, I'm defining them both as an input output here. So I can take, they're like they can behave both as an input or as an output. Let's say okay, I'll take an input, so I have to remove this out here. So you can give all the pins at the same time with a space between. So this is for R is for rotate. I'm rotating it. This is for in. Okay. So again, I will go here. This is for rotate. I'll same for this one. Okay. So I'll drag it here and I'll press this line. Now these three connections are done. Now the output is remaining. Again, I'll go for pin. I'll write out here OUT and output hide. Okay. So once all the pins are connected, I'll do check and save. It shouldn't give me any error. So it's not giving any error. So next thing is I'll give label, and I'll go in and out. In is for this one and out is for, okay. Again, I'll do check and save. So now the pins are done. So how to give the stimuli? How to see the simulations of this circuit? So again, I'll go for ADL. Okay. So here earlier we used to everything was defined. Input supply was defined. VDD was defined. So but now I have to define these pins. So for that, I'll go to setup, and here this stimuli is there. One thing, or here this shortcut is there. You can press on here. So it is giving me 3 pins which I have to define. So I'll first enable this VDD, and I can choose whatever source I want. So for VDD it is a DC supply, so I'll give 1.8 volt. Okay, I'll apply it. Similarly for ground, I'll give 0 volt. This is the procedure you should also follow for when you are going for schematic layout. And when you are you have to remove all the pins, so you want to check it and like that. So for pulse, I'll give this one. Let's keep this DC voltage as variable. I want to check the VTC also, like earlier in tutorial I said, and I'll give here again 20 nanoseconds. I can give delay time also, rise time, fall time. By default they are 0. If you want to define, you can define. So pulse width by default it's half of this one. If you want to define, you can define that also. Okay, I'll just press OK. Again I'll see okay, everything is done here. So this is it. Now I'll choose the analysis DC. I'll say the operating points, apply transient, and I'll give here 100 nano. Okay, conservative I'll choose. Okay, and for output choose, I'll go here, select output from design. Okay, and I'll choose out and in, and I'll press OK here. Now I have defined one variable here, x. Okay, so I have to define that x here. So earlier in schematic when I defined, I could have done copy from it was coming, but now I had done it stimuli, so it won't come through here. So I had to give it here manually x. I get 0.6. Okay, now again I'll DC, I'll vary that variable x. It will show me here this x, and I'll vary 0 to 1.8 input I'm varying. Okay, So now let us see. It will give you both VTC as well as transient response. Now as you can see here, okay, so this is the VTC when I am varying X, and the output is varying like this, and this is for splitting. You can see here, this is output, this is input. Okay, so these are the things up till when you are going for a layout, so you have to keep this thing in mind. So now I am saving this. Okay, and now there is this directory. If you are saving in directory, it will be saved here in this one. It will be saved here in Cadence outside, like here. But it's better, it's advisable to save it in cell view, so that it will be saved inside of this inverter, because when you do a lot of simulations, it will mix it may get intermixed with other simulations. So it's better to keep every one simulation to their own file. So I'm saving it. Okay, so I'll close it. Now I saved it. Again I'll go to my inverter. Now this thing is done. Okay, now I had created a symbol. So for that I'll go for this create, and I'll go this cell view, from cell view. Okay, I'll just press OK, and now I have to define left right pin. This is GUI, simple. For your convenience, you can define in which way you want. So let's take, I'll take VDD here. It should be same as the name you have given in your schematic. Okay, okay. So this will, one more window will pop up. So what you will do here, you delete all these things. Okay, and this one also, and double click on this instance name. Once this is highlighted, you will type your thing inverter. Okay, and press enter, and you can drag it here also. Now it's your wish. You can keep this symbol as a block, square box, as an cube, as a triangle. You can make it similar to an inverter. So we'll make an attempt. So you go here, you select a wire, and we'll start from here. Okay, go like this, go like this. Once you reach here, double click there, press escape, and you can drag it a bit inside. Okay, let's make one circle. Click and go wherever you want to go. Okay, see, it looks like this, but internally they are connected like inverter. It is for our own convenience, so there is no need like beat your head about this accuracy and all that connections should. Yeah, it will look good, but it is just formality. Okay, ground. I'm just trying to make it look better. There's nothing, you can stop there also. So I can do like this. What I'll do, no, it's not going. Okay, so let's keep it like this. Okay, this is it. This is the symbol for inverter. So once you done check and save, then you can close it. Okay, I'll close this one also. So now I had to use this symbol in my some other circuit. So for that I'll create like this new cell view. I'll give this trial. Okay, so I am giving this trial where I am going to use the inverter symbol. Again I'll go for instance, browse. Now I had to use my inverter. So for that I had to go to my own library. There's Cadence. I'll select this inverter and it will give me here symbol. Okay, so symbol I'll keep it like this. Okay, I'll press F. Now this is the, now if I want to simulate it again, I am taking different nets so that I'll define pins. Okay, let's define first out. Okay, then I'll define VDD in GND, and I'll put this input VDD GND. Okay, okay. So once this is done, I'll do again check and save. Now I'll launch. Now since all the inputs are here same, like VDD ground and they are both same saved. Earlier I saved that state in that cadence inverter. So I'll go here, cadence is my library. I'll select cell view here, cadence here. I'll select inverter, and it will give me that state which I have saved earlier. I'll launch that one only. I'll run it. It should give me the same result. So this is how we use symbols in our circuits and how to create symbols. So in this tutorial, what I did, I removed all the sources which I used earlier, VDC, VDD, etc., and ground. Then I used pins, and this is the same process. When we had to go for layout, we had to remove all those things and replace them with pins. Then we'll go for layout. So in next tutorial, I'll be showing how to use calculator. Like I want to calculate the delay of this circuit, rise time, fall time, and I can calculate different utilities which are there. So in calculate, I will try to show some later on with by time. Whenever it's required, I will be showing how to do those simulations.